Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2128, refers to a high voltage reading in the APP sensor B, often known as the throttle position TP sensor E. This issue is primarily linked to the accelerator pedal position APP sensor, which plays a crucial role in vehicle performance. It detects the position of the accelerator pedal and sends this information to the Engine Control Module, ECM, to adjust engine power and optimize fuel efficiency. The APP sensor is typically located near the accelerator pedal assembly inside the vehicle. When the APP sensor sends a higher voltage signal than expected, it triggers the P2128 code, indicating a possible malfunction of the sensor or related wiring. Before proceeding with repairs, it is vital to gather all pertinent diagnostic data, including freeze frame data, which provides a snapshot of the system's condition when the fault was detected. But the APP sensor B, also known as the TP sensor E, measures the position of the accelerator pedal and sends voltage signals to the ECM. The ECM, which is the brain of the vehicle, interprets these signals to manage throttle response and engine performance. The APP sensor is located at the base of the accelerator pedal, ensuring a direct connection to the pedal's movement. It is critical for maintaining optimal engine performance and fuel efficiency. A high voltage reading from this sensor may suggest an internal fault, faulty wiring, or a poor connection. The P2128 code indicates the signal is higher than expected, commonly pointing to the APP sensor itself as the primary suspect. Additionally, nearby components or wiring, like the SG5 line, may contribute to the issue. Several issues can lead to the P2128 code being triggered. A faulty APP sensor is the most common cause and can arise from internal damage or wear. Wiring issues are another potential source, as damaged or frayed wires can send erroneous voltage readings to the ECM. Poor connections at the sensor or the ECM can also lead to intermittent high voltage signals. It's crucial to examine the wiring harness thoroughly, looking for any signs of wear, corrosion, or loose connections. Additionally, software anomalies in the ECM could also cause incorrect readings, making it important to check for software updates. Each of these potential causes must be investigated during the troubleshooting process. When the P2128 code is present, various symptoms may be exhibited by the vehicle. One of the most noticeable indications is the illumination of the check engine light on the dashboard. Drivers may also experience poor throttle response as the ECM struggles to manage engine power with incorrect signals from the APP sensor. In some cases, vehicles may stall intermittently, particularly during acceleration or deceleration. Additional symptoms may include difficulty in engine idling and erratic acceleration. Understanding these symptoms enables technicians to correlate the DTC with potential mechanical issues, forming a comprehensive diagnostic approach. Recognizing these signs early can prevent further damage to the engine or associated components. The first step in troubleshooting the P2128 code is to verify the problem. Begin by turning the ignition switch to the on position without starting the engine. Using the Honda Diagnostic System, HDS, check the voltage reading from the APP sensor B. It should be approximately 4.0 volts or above for the issue to be considered valid. If the voltage meets this threshold, the failure can be duplicated, allowing you to proceed to the second step. If the voltage is below this level, the issue may be intermittent, suggesting that the system could be functioning correctly at that moment. During this scenario, it becomes essential to inspect the wiring for poor connections or loose terminals at both the APP sensor and ECM, as these can cause fluctuating signals. In this step, the focus shifts to determining the specific area of failure. Start by turning the ignition switch to the lock position. Next, disconnect the APP sensor's 6P connector. Once disconnected, turn the ignition switch back to the on position. At this stage, you will measure the voltage between the designated test points. Test point 1 refers to terminal number 2, LT blue wire on the APP sensor 6P connector, while test point 2 is terminal number 3, gray wire, of the same connector. The voltage reading should be around 5.0 volts. If you achieve this voltage, the APP sensor is likely the culprit, and replacement is warranted, followed by repair verification. If the voltage does not reach that level, the issue lies with the SG5 line, requiring further investigation. The third step focuses on assessing the continuity of the SG5 line, which is crucial in ensuring proper communication between components. Firstly, turn the ignition switch to lock. Use the HDS to jump the SCS, Service Check System, line. After doing this, disconnect the ECM connector A, 49P. For continuity testing, connect a jumper wire from the APP sensor's terminal number 2, LT blue, to body ground, effectively grounding that point. Verify the continuity between the defined test points. Test point 1 is the LT blue wire at the ECM connector A, 49P, terminal number 45, while test point 2 is the body ground. A positive continuity check indicates the SG5 wire is functioning correctly, necessitating further actions like updating the ECM if the software is out of date. A negative result signals an open in the SG5 wire that must be repaired before moving forward. Following successful repairs, a thorough verification process is essential to confirm the effectiveness of the actions taken. Start by turning the ignition switch to the lock position and reconnecting all connectors that were previously disconnected. Once all connections are restored, turn the ignition back to the on position. Next, use the HDS to reset the ECM, which allows it to recalibrate after repairs. Perform an idle learn procedure to ensure proper engine function. Finally, check for any pending or confirmed DTCs using the HDS. If the P2128 code reappears, further inspections of connectors and terminals must be conducted. If the code does not display again, the troubleshooting can be considered complete, ushering in an opportunity to address any additional DTCs that may have arisen. To avoid encountering the P2128 code in the future, it is crucial to implement a robust preventive maintenance plan. Regular inspections of connectors and wiring harnesses can help identify potential issues before they escalate into serious problems. Checking for corrosion, loose connections, or frayed wires should be part of routine maintenance. Additionally, keeping the software of the ECM up to date will ensure that the vehicle's computer operates with the latest fixes and optimizations. Performing regular sensor tests can also help in early detection of sensor faults, enabling timely repairs. Additionally, drivers should monitor any changes in vehicle performance and address unusual symptoms immediately to maintain optimal engine functionality. In conclusion, understanding the role of the APP sensor and its relation to DTC P2128 is crucial for effective troubleshooting and repairs. The APP sensor plays a vital part in determining engine performance, and issues around its signaling can lead to a variety of symptoms impacting vehicle usability. Identifying any wiring issues early on can help prevent further complications. The troubleshooting steps outlined provide a systematic approach to diagnosing the root cause of the problem. Furthermore, maintaining preventive measures, such as regular inspections and software updates, can mitigate future occurrences of this DTC. By adhering to these guidelines, vehicle performance can be sustained, ensuring both safety and efficiency. Please like and subscribe to the channel. See you next time.